yeah.
I'm just curious because the panels, like it doesn't make, like a car battery is like 75 kilowatt.
Yeah.
And yet these things are 5 kilowatt.
Yeah.
And they're like, it'll take about, they go, with the way they work it out, it's about 11 grand total. If you've got about 9 solar panels, it'll take you about 9 years to pay.
Yeah.
But they've got 25-year guarantee. That means.
Yeah, but obviously you don't know if they're going to be around next year. No money, 25.
But these testing do something.
So they're decent. They're good ones.
Well, they're big brands, and so you expect them to be around.
Yeah.
How they work.
I don't know, man. I mean, but the thing is, that's just assuming that nothing goes wrong. You don't have to fix anything in that time.
But some people have, like a friend of mine, he's had them for 7, 8 years.
I mean, is it okay?
People say the invertibles, he's got a single inverter, and he wants to have end phase, they have whatever it is, like an inverter on each one of the solar panels separately.
Okay,
So if one goes,
the other ones carry on working. But how much power does he actually get from them?
440 watts. So basically,
We're good?
Can you go back there?
Yeah.
When I say go, you're live already anyhow.
Yeah. Okay.
Okay, boys, inshallah, we're starting, okay? Okay, 1 second.
Okay, Assalamu alaikum everyone. Thank you for coming, thank you for joining us. This is the second set of courses, second set of lessons. Obviously, we had one last year, and we do see some familiar faces from last year. But yeah, Automotive Design, Manufacturing Concepts, second course, 2024. With me, my name's Sharaz Sultan. And I'll just run through sort of a quick plan of what's going to be happening over the next 4 weeks. So obviously, week 1, which is this week, is an introduction, and it's a recap of some of the stuff that we went over last year. So the ones that were here last year, some of this is going to be familiar to you, but obviously the ones who have joined us the first time, it'll be a quick intro. Week 2, we're going to have a lesson. Week 3, which many of you are aware of, we've got a field trip to the British Motor Museum in Warwickshire. So hands up for who sort of booked and paid for that here. Anyone else? Okay, so good for your number. That'd be a good trip. So that's on actually a Sunday. So that's Sunday, the 22nd of September. So it's the 3rd week from now. It's not on a Saturday, so don't turn up on a Saturday here expecting to go. There'll be nobody here. Doors will be shut. So that'll be on the Sunday. But the details for that will be sent out, through the relevant ways. A few things for that day. What I suggest is you need to have comfortable footwear. Again, we'll go over this. A coat if the weather's bad, because on the day there's actually a car show going on as well for Jaguar cars. So we can have a look around there before we start the full tour of the museum. So you can have a look around. And a packed lunch as well. So we need a packed lunch, but again, details will be sent out closer to time. Week 4, which is the last week, obviously that's going to be the final lesson and the course completion, and maybe just a quick once-over of everything that's gone on so far. So, a bit about me. I was born in Halifax. Anyone know where Halifax is? West Yorkshire. Well done, yeah. Best town in the land. I loved cars from an early age. I guess you guys like cars as well? Yeah? Nodding heads? Good. I studied mechanical and automotive engineering, and then I went to work for Ford Motor Company in the UK and Europe, and then Jaguar and Land Rover. So I worked on the Ford Fiesta, the B91, and the BMW designed Range Rover, the first generation Range Rover Sport, and the L319, which is the Discovery 3/4. So that's me. So what we'll do is we'll do a quick walk around the room and just introduce yourself, and just a couple of things. Your name and your favourite car. So we'll start from the right. So Yusuf, what's your name and what's your favourite car? You? Yeah, no, that's fine. With a cap, you can begin. Zachariah, and what's your favourite car, son?
Mercedes Maybach.
Mercedes Maybach. Good choice. Bit of luxury there. Abdul Qadir, okay, and favourite car? You don't have a favourite car? What car do you like the look of? Any car, as long as it's got 4 wheels. Okay, that's fine. You missed a 1979, which is obviously the best year. AB, 1979, best year, yeah, obviously. We were obviously born in that year. Madge, you missed out by a couple of years, so sorry. What's your name? Ismail. A G-Wagon. Okay, another good choice. Okay, and what's your favourite car? You don't have one. Okay. Struggling to see? Okay, and what's your favourite car? Oh, come on. You back there. And favourite car? Why? We're not going to hold it against you. And it's a micro. Okay, you like it's a micro then. What about you? Which one?
Huracan STO.
Huracan STO, Lamborghini, okay.
My name's Aaron, so
McLaren F1, okay, good choice, good choice. Mr. Madge?
What car do I like? RS6.
RS6, okay, good choice.
Audi.
Audi, any Audi. MashaAllah. Brabus G-Wagon.
my name would be on the M5 competition or Nissan Skyline.
M5 competition.
34.
R34, okay, an M5 competition, that's a good choice. Audi RS6, there you go. Look, we've got another RS6 fan. Which one? RS6 as well. Brabus G-Wagon. Okay, okay. Osama RS6, okay. Porsche GT3 RS, proper car, okay. Rolls-Royce Phantom. That's a sort of in competition with the Maybach there. Nice choice. M3 G80. That's a good car. That is. That's a good car. V8. Range Rover SVR. Okay, and that's a good choice as well. So we've got like quite an eclectic mix of cars, and obviously you've all got your favourites, even the ones who like the Nissan Micros back there, or prefer not to say because it's some kind of national secret. But that's fine. But look, we all see cars going out and about, and you see something, and you think, wow, beautiful looking thing as it's moving or as it's parked. But then there's a lot more that goes into it. There's a lot more thought that goes into it, a lot more development that goes into it. Now, just to give me an idea. How long do you think it takes to develop a car from somebody saying, right, we need a car, to when the first one rolls off the production line? Normally speaking, how long do you think? Give me a time frame.
5 years.
5 years?
10 years.
10 years? 18 years, okay, okay. No, well, it's around about 6 years, 5 or 6 years, generally speaking, for something like that. So that's how long it takes before you can have a car on the road. So all these cars that you see, literally thousands of people have worked on the design and development of them. Every single part, so when you get into the car, you're pulling a door handle, there's a whole team designing that door handle. There's a production company that makes them. They have engineering drawings for all this kind of stuff. So any small insignificant part you think on a car, and these are just the bits that you can see, they're all being designed. And then obviously there's stuff that you don't see, which is underneath, inside the engine and everything else. And all that obviously is designed. So, what is a car? Well, English word for car, it originated from the Latin word carus, which means a wheeled vehicle. That's one of the first cars. So basically, it's just 4 wheels, and it's being pulled along. What do you think that was pulled along by? Yeah, but obviously it's on the wheels, but it's got no engine because it's before engines. What do you think it's pulled along by? Horse, yeah, well done, horse. And that eventually goes to something like this. So they're obviously more modern supercars, hypercars of nowadays. Anyone name any of them? There you go, well done. Good man. So, how long do you think it took to get from the first one to these? How long? Century, 100 years?
Yeah, I'd say about over a century.
Over a century? 2,000 years? 350 years? Okay, quite specific. Back there, Mr. Micro? 9,000 years. Not any more? 220 years. You're just waving at me. Okay, I thought you wanted to answer the question. No? Okay. It was actually 5,000 years, so that's how long it took. So that just gives you an idea of the amount of development. But looking at sort of car development, most of that development has really happened in the last 100 years or so. So the cars that you see now, with the features and stuff that they've got, most of that development took place in the last 100 years or so. Okay, so again, we went through this last year. I've changed some of the slides. And what we're going to do is, these are sort of quite specialist cars. So, if you know them, that'd be fantastic. So, anyone guess what car this is? Bentley? A Bugatti? Mercedes? Jaguar. It does look a bit like a Jaguar, doesn't it? Like an old Jaguar. Rolls Royce? Rolls Royce? Rolls Royce? Chevrolet? Okay. Bugatti? Any more? Okay. Yeah, it's a Morgan, but I knew you'd know, but because you know what? Yesterday you were saying, "Oh, let me go through the slides." Yeah, let me go through the slides. Right, you are banned from answering any more questions. Okay. So that is a Morgan, and it's actually a Morgan Aero 8 Max. Right. One little story about Morgans is they were actually made for many, many years using what material do you think? What material are cars generally made out of? Aluminium. What else? Steel, yeah. Anything else? Yeah, they do have glass in. But Morgans, the body panels on them were actually made out of wood. Yeah, so wood. So, some of them had the exposed body frames on the outside, so, on a Sunday you could varnish them or change the colour if you wanted to. Yeah, so I think they're aluminium now, and they're not made far away, they're actually made in Worcestershire somewhere. It's not a million miles away from here, and they still make cars. Right, this one.
Back to the Future.
DeLorean, yeah. So, yeah, good. Obviously, it wasn't Back to the Future, but it's a DeLorean. What is it? GMC? Yeah. It looks like that, but it's actually DMC, which is the DeLorean Motor Company. This was the brainchild of a guy called John DeLorean, who was a high executive in the American auto industry. And then he wanted to go it alone, make his own car. And they actually, do you know where they built these? It was designed in America. Do you know where they were built? Ireland. So yeah, so sort of early 80s, the government gave lots of money to the DeLorean Motor Company to set up a factory, provide jobs and everything else. Unfortunately, it wasn't a success because of different reasons, and you can read the history about that. But yeah, ever immortalized in the Back to the Future movies for the gull-wing doors. Anyone else can name a car that's got gull-wing doors? Yes. Tesla? Yeah, the big one. The one with the wings and stuff. Yeah, cool. So yeah, DeLorean DMC-12. Right, next one. Now this is a tricky one. And if anybody can get this, I will be well and truly impressed, right? Ready? Yeah? What's that? A Land Rover. Range Rover? A Jeep? Jeep? Lamborghini? Toyota? Volvo? Mercedes? Land Cruiser? A Jeep? What is it? A Ford? Lamborghini. Who said Lamborghini here? Well done. That man knows his cars. This is actually a Lamborghini. Who was it? Oh, you. Oh, okay. Well done, you. Right. Keeping an eye on you. There you go. So that is actually a Lamborghini, believe it or not. It's an LM002. Yeah. Because that was obviously the grandfather of the Urus or Urus or however you pronounce it.
They're making fun of me because look how beautiful this is.
You know, originally they made these for the army, but again, it wasn't too much of a success because there was other car manufacturers. And then apparently the story goes, the Sultan of Brunei wanted one, and they kind of put an engine from a Countach in it, a big V12. I think it might have been turbocharged as well, and sort of took off from there. They didn't really make that many of them, but yeah, that was sort of the first really powerful 4x4. Right, what's this? Ford?
I know.
Ferrari? Ferrari? Porsche? Ford? Ford? GT40? Okay, yeah, it's a Ford. Well done. And it is a GT40. Anyone know why they call it a GT40? No, you can't answer this. You are banned. Anyone know? Bro, shush. Right, I can't hear. Yeah, it was in a film, but do you know why it's called the GT40? That's a good guess, but not quite right.
40 centimetres off the ground.
40 centimetres off the ground? No, you can't answer it. Anyone else? Yeah, you're on the right lines. Kind of on the right lines. Basically, it was 40 inches high. So, yeah, 40 inches high. So that's the reason why it's called GT40. Yeah, so you have to be quite small. And with this car, the fuel tanks are actually called bladder tanks, and they're down the sides of the sills. So you don't really want to get T-boned by it because you haven't got a solid fuel tank. It's kind of it's made out of some kind of rubber type material, and it's flexible. So yeah, that's the story with that. That was only designed as a kind of in retaliation because Ford Motor Company wanted to buy Ferrari, and they were kind of messing them about and saying that you're never going to be able to build decent sports cars. So Ford went and designed this, and they actually won Le Mans, and it came first, second, and third on the first outing, which was quite good. Right, next we're going to go on to engines. Now, I know obviously we're in 2024 and there's a lot of electric cars flying about. Me personally, I've never been a fan of electric cars. Still not 100% won over by them. So I think the internal combustion engine is going to be here for a while. Internal combustion engines, you can actually think of them as air pumps. So people think that, it's an engine, it's producing power, but when you look at it from an engineering point of view, all it's doing is it's moving air. So the more air you move, what's that going to make? Power, yeah. So engine can be thought of as an air pump. So the more air that goes in, the more power it can produce. So what else do you need apart from air in an engine?
Fuel.
Fuel, yeah. What type of fuel?
Diesel, petrol.
Diesel, petrol. What else? Well, that's sort of more for an electric motor car. Obviously, this is for an engine. So you could use, biodiesel, bioethanol. In Brazil, they actually use fuel made out of sugarcane. What's that, sorry? Batteries, yeah. Well, you need a battery, but the battery is just literally to get the engine going. A key. Spark. Right, so you need fuel. So just to give you an idea, how many litres of air per minute, because obviously an engine's an air pump, don't forget, yeah? How many litres do you think a person needs a minute? 10 litres of air. So a person sort of doing their normal thing, do you think would need about 10 litres of air a minute, yeah? 5? 120 litres. So if you imagine, you get the litre bottles of milk or whatever, you need 120 of them. I mean, that's quite a lot. 1,002. Yeah. Otherwise, you can come up here and do the course, and I'll come and listen to you. Okay, that's a bit of a more sensible answer. Right, 6. 6, right? Right. A small car, how much air do you think that needs a minute? So bear in mind, a human needs 6. 500? 700?
300.
350?
260.
150?
2000.
3,000? So if you imagine got a human being needing 6 litres of air a minute, going to a small engine needing 3,000 litres. Now that's quite a lot. So if you imagine all that air, if the air's going in, it's all got to come out the exhaust. So you know when you see the cars and they've got these tiny little pea-shooter exhausts, like this V8 500, imagine 3,000 litres of air is coming out of that a minute, which is quite a lot. Okay, and so Formula 1 car, how much do you reckon? How much?
70, 15,000.
20,000.
20,000?
10,000.
50,000.
200,000.
200,000?
75,000.
75,000?
10,000.
10,000? Okay. So we're getting lots of numbers.
Also, I told you that's 80.
18. 18. I think that's Lewis Hamilton in that car. So yeah, 18,000 litres of air a minute. And the other thing is, in any type of motor racing, they have to sort of try and keep it as a fair playing field. So what the way they actually limit the amount of air going into the engine, how do they limit the amount of air going into the engine? Because obviously if that's limited, you're going to limit the power. How do they limit it? Yeah, so the intake might be, I don't know, 35 mil or 40 mil or 50 mil, which is quite small really. So that's the only sort of volume of air that can go through there. So that's quite interesting really. And if you imagine how much power these cars produce compared to a normal road car. Okay, so how can you get more power from an engine, do you reckon? We're talking about the air principle here. So what we want to do is try and get more air into the engine. Yeah, how would you get more power? So there's 3 ways. Yeah, a remap, so what that would do is, that would, that would do it, but I'm talking about to try and get more air into the engine. How would you get more air into an engine? Because obviously, if you imagine, if you're at, we're here in Birmingham, whatever the air pressure is, however many bar it is outside, normally 1 bar at sea level, that's the amount of air going in. Now, what you want to do is you want to try and force more air into the engine. If you can force more air into the engine, you can produce more power. Obviously, by doing that, you've got to put more fuel in as well. So how can you do that?
So, increase the air tank, increase the fuel, and put nitro into it.
Yeah, so you've got one of them. The nitrous is one way of getting more air in. Why is nitrous one way of getting more air in? Okay. Now, obviously, you guys are all at secondary school, yeah? So you've done sort of chemistry and physics. How much oxygen is in the air that we breathe normally? As a percentage?
Of oxygen. 21%.
Well done. Yeah, 21%, around about 21% oxygen in the air that we normally breathe. Now, nitrous is a bit more than that. How much is in nitrous? Nitrous oxide?
39.
You're not far off, about sort of 36, 37%. So you're putting more air into the engine. So anyway, let's go through it. So try and get more air in. So you use a supercharger. Yeah? So what you're doing is you're forcing more air into the engine. So going along that theme, supercharger, what's the next thing? A lot of cars have these. Turbos, turbochargers. Turbos. And obviously you've got the nitrous oxide as well. And they all work by increasing the amount of oxygen that's going into the engine. So the more oxygen you have, the more power you have. That's why if you're ever driving, one day you're going to be driving your own cars. If you're driving in sort of a really hilly area, high altitude, the engine's going to be struggling to produce its maximum power because the amount of oxygen is lower. I mean, they say the air is thinner, but the amount of oxygen in the air is less. And modern cars, the computers actually work that out and then adjust the fueling and stuff and drop down the power just to make sure you can carry on driving. In the old days, you'd have trouble, so you'd have to open the bonnet, set the carb and everything to carry on driving. So yeah, more oxygen equals more power. Okay, so superchargers and turbochargers. So there's going to be pictures of each one. Which reckon is which? So what's the one on the left? That's a turbo, yeah? Turbo? So the one on the right's going to be a supercharger, yeah? So a turbo, they actually call it a snail as well. So that's kind of a bit of a slang word for it. So if you're into cars, they call it a snail because it looks like a snail's shell. Obviously the supercharger, is on the right, so it's a bit more bulkier. Superchargers were actually developed for planes, high altitude military aeroplanes, because with the turbochargers they could actually stall, but because does anybody know how a turbocharger works? Yeah, but how does it spool up the air? Because obviously what it's doing is it's spinning the air, compressing the air, so you get more air forced into the engine. What actually turns it to spin it? Exhaust gases. Whereas a supercharger runs off, it actually runs off the engine itself. So if you've ever been in a turbocharged car, or you've driven one or whatever, when you put your foot down, you feel nothing, 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 and then all of a sudden, when the turbo kicks in, you're off. With a supercharger, it's a bit different, so you get more power from the off. So, you know, a lot of the Mercedes, they're supercharged, so if you have a look on the back, some of them say compressor, that's a German full supercharger. I think they're probably the only ones that do superchargers generally. Most cars are turbo, because a turbocharger is a bit cheaper to make, so that's the reason why they're kind of fitted to most cars. Okay, next thing is concept cars versus final design. So you know when they design a car, so you know you talk about cars and you see some cars which you think look beautiful, and then you see some cars and you think, why would they have actually made something like this? Nobody would ever buy this. All them cars, they've actually been a concept car, so somebody somewhere has decided, or a group of people have said, look, we actually like the look of this car, we want this car and we want to see it on the road, we want to drive this car. So these are some concept cars, and so that's a concept car. So what do you reckon that's a concept car of? So that car did make it into production. It didn't look exactly like that when it was finished, but it did make it into production. So you think that, yeah, it does look a bit like a new Jaguar, doesn't it? One of the new Jaguars. I can see that with the grille and with sort of the round badge. Subaru? Mustang? Subaru? Ford? Okay, that's actually a concept of the Subaru Impreza. And that's what the final car looked like. So you can kind of see the similarities. Yeah? See the similarities? Slight design. Concept cars very rarely make it into production because the designers go wild and they don't care about if it's possible to make it, if it's going to be legal to make it, i.e. no sharp edges, things like that. If it's going to be comfortable, if it's going to be practical, all they're looking at is an idea, and they farm it out to potential customers to see what they should be doing. Right, next one. I think this one's a bit easier. Mercedes? Mercedes, yeah? Okay, we'd all agree it's a Mercedes. So why would you say it's a Mercedes?
The shape.
Yeah, because of the shape? Yeah. It's got the what, sorry? Yeah. So it's got the TriStar, which is part of the Mercedes logo. It hasn't got the badge on the wheel. I was waiting for you to say that. But with the Mercedes, it's sort of quite curved. So you've got the roof line, it's normally a continuous flowing curve. So that's sort of a trademark of the Mercedes. So that was actually the concept car for the Mercedes EQS. And that's what it turned out like. So that looks pretty similar, I think. Yeah? You guys think that looks pretty similar? It looks what, sorry? It doesn't look nice, yeah. I mean, I'm not really a fan of the Mercedes, the modern Mercedes, but again, it's personal preference and some people love them.
If you look at the back of the concept, it's curved outwards. If you look at the back of the car now, it's curved inwards.
Yeah. So that's probably a slight change because do you know why they might have had to do that? Anyone hazard a guess as to why they might have had to do that? No? I think more than likely, what was that? Safety is normally at the front. So you know you have crumple zones on a car to protect passengers, pedestrians and everything else. That might have been a consideration, possibly. I don't think so because they could probably mount the number plate. No, I think it's probably down to aerodynamics because as the car's going through, it's got to be aerodynamically efficient because if the car's aerodynamic, it's going to use less fuel and it's going to be quicker as well. Yeah, exactly. So go faster. So you see these cars with like little spoilers and little scoops and all that. All that's been designed and that's actually been designed in something called a wind tunnel. So what they do is they take a model of the car, put it into the wind tunnel, blow air through it, and then with computer analysis, they analyse where the air is flowing, and then by that they make slight changes to try and improve the aerodynamic flow. Do you know what the most aerodynamic shape is? No. It is kind of a curve. Similar to an egg, not quite, but not far off. Any ideas? No, circles, not very efficient. Flat, no. It's actually sort of a raindrop or a teardrop. So if you imagine sort of that kind of shape, most aerodynamically efficient shape. So that's why, you have a look at fast cars, or if you ever watch cycling and you see the guys' helmets and stuff, they're sort of shaped like a teardrop. Simple reason is it's the most aerodynamically efficient shape. So everyone's got to try and get to that. So if you imagine, you've got the curves and stuff, and it sort of sharpens off to a tail on the end, and that's the reason for that. Okay, and right, car speed records over time. So what's the fastest production car at the moment? Anyone know? Which one? What's the speed on that? 500 kilometers per hour. But I'm talking about a standard production car. Yes. Bugatti Chiron. Koenigsegg. I think. Yeah, Chiron Super Sport with a longer tail and stuff. That's called sort of the fastest production car, and that's around about 300 miles an hour. So that is a car that you can buy, and you can get to 300 miles an hour if you've got a private road that you can take it down. So that is. So this guy, he actually got a world record with that car for being the quickest car. So this was made by a guy called Camille Gianazzi. Anyone know what that flag is? Belgium. Well done. Well done. Yeah. So he's from Belgium. What year do you reckon this was? 1980. Okay, whoa. Right, so we have got lots of opinions on this. 1899. 1899. Yeah, so around about 125 years ago. So, and what do you reckon his top speed was? What do you reckon he got a world record at? Bear in mind, we're at 300 miles an hour now. 10? 40? 85? Right. 60? Oh, but if you imagine, I mean, we've only come another 240 miles an hour in 125 years, so I think personally he did pretty well there. Anyone know what's special about this car? Like a bullet, yeah. I mean, it actually looks like he's driving it on his wedding day. I don't know if that's his wife on the back or whatever, but with all the flowers. Taxi? No. It was electric. It was electric, yeah. Can you believe that? It was electric then. Well, lead acid batteries there would have been, and there would have been a lot of them. So most of that would have been storage. Right. So let's go to the quickest car. Anyone know what holds the record for the quickest car? Non-production. Yeah, Trust SSC. And so, what type of power plant does that use? Do you know what type of power plant it uses?
Solar.
Solar. Hybrid.
What? Wait.
That's what it looks like. Right. Right. I mean, it doesn't look like a normal car, does it? Yeah? Yeah? Right. Doesn't look like a normal car. Yeah, it does look like an airplane, doesn't it? Yeah? So you know the two round things on the side? Right, two round things on the side, what are those? Rockets. Jet engines, well done. So it's got two jet engines. So it was actually designed and then driven by a guy called Andy Green, along with a guy called Richard Noble. They're British, from the UK. What year do you reckon this was?
2011.
No, one at a time. 2018? 2012? 2004?
2002.
Okay, so we're all in the 2000s. 97? And that car still actually holds the record. Right. What do you reckon the top speed was?
6,000.
No, I'm not going to ask you. 678,000. What, miles an hour? 678,000 miles an hour?
No, they wouldn't even survive 7,000.
It's about 600.
8,000.
455.
Right. Right, it was. Whoa. 766 miles an hour. Right. Do you know what's special about 766 miles an hour? What's that quicker than? So it was supersonic. So what does supersonic mean?
Oh, faster than sound.
Faster than the speed of sound. Faster than the speed of sound. So what is it? So it was actually faster than the speed of sound. So do you guys know what a sonic boom is? Yeah, when you actually go through the sound barrier. Yeah, you're going past the sound barrier, and basically the sound waves. So if you easiest way to imagine it is if you imagine a boat going through the water, and it's going through, you've got the wake, which is the water going past it. Now the object is going so quick that it's actually going through that. So it actually goes past it before you actually hear it. So normally, if you're at school and somebody's playing football, somebody kicks a ball and they're a bit way down the field, normally you hear the sound, don't you, before you see it. So you hear the sound and then you see it, yeah? This is obviously the other way around. We have got a video here. I don't know if it's going to play or if the sound's going to play. Hold on. So this was the high-speed run. Can you hear that? I think that's a bit low. Right. For our viewers online, so there was sound there when it's actually broken the speed of sound. So it's gone through that. It looks like it's gonna? Yeah, well, it is dangerous, and lots of people have actually lost their lives in the pursuit of speed. So obviously these guys are quite lucky, but you know there's been lots of cases where even in air, on water, on land, people have actually lost their lives because you're actually pushing the boundaries. You're pushing the boundaries.
If someone's driving like that,
Right, hold on. Look, somebody's asking a question. Maybe we can all learn from this.
if someone's driving that fast in that car, then they just float over water.
They could what? Sorry.
Then they float over water.
Yeah. They could do. Or what else do you reckon could happen? I mean, you're going at that speed. What do you reckon could happen?
If they crash, they could fly out.
They definitely would fly out. I don't think the seatbelt would help them.
So if they were to crash into like a wall that's like one brick they're just going to go straight through it and it's probably going to explode.
Yeah, but the reason why they sort of they do this I mean, if you go back to there, let me see where that. So if you have a look, they actually do these high-speed runs in the desert. So it's basically old salt lakes which have dried out, you know, many, many years ago, and they're pretty much flat. Yeah. So they have to do it in a great big open area, because otherwise, you know, you're not going to have the space. And you're right, you can't do this on a normal road, you can't do it on a normal test track. So most of these cars, they take them over to the salt plains in America, and that's where they do the high-speed runs. Well, to be honest, do you know how these cars brake? How do you think that would apply its brakes? Parachute, yeah. So normal cars use, you know, discs and pads, so you see them. On some cars you can see through the wheels and you can see the disc, you can see the caliper and everything else. These actually use parachutes because the normal brakes will just burn up. Because the car's going so quick and you've got so much momentum, the normal brakes just wouldn't work. So yeah, they have a parachute on the back just to kind of slow them down. And just a little fact, when they do high-speed runs, they actually have to do 2 runs, just in case one side has got a slight gradient on it and it's a bit easier for the car to go. So they do one way, one the other way, and they take an average of the 2 runs, and then that's the sort of final speed. So yeah, that car there still holds the world speed record. They did decide to do another one called the Bloodhound, and they started making it. They've got a concept. Half the car's built, but they stopped that about 10 years ago because they simply ran out of money. Because to do something like this literally costs millions and millions of pounds, because you're getting the very best of everything.
How do they transport that car to places?
Well, the way they do it is they do it in pieces. So they'll probably more than likely take the engines off, take the jet engines off, and the car would split up into maybe 1 or 2 pieces. Or what they do is they can actually take it on a plane as well and transport it that way. Yeah. This car, they've actually got this car. Actually, I'm not sure if they've actually still got it, but a couple of years ago they had it at the Coventry Transport Museum. Yeah, have they still got it there? Yeah. So if you ever go there, you can actually see this actual car, the one that actually broke the speed record.
How much would that car weigh?
Not sure, to be honest, but many tons. So it's going to be heavy. It's not going to be light because obviously the size of it has to be so big to not fall apart at these speeds. So it's got to be fairly big. I mean, this car, I think from memory, it was probably maybe 15 meters long, something like that, 20 meters long. You know, so it's like a big thing, and it's heavy as well. And I mean, if you have a look in the cabin of this car, it's not really somewhere where you'd even want to sit in for a minute. Never mind for maybe 10 or 15 minutes doing over 700 miles an hour. And because obviously there's no safety nets. I mean, you know, a seatbelt's pointless. There's no point having an airbag. If something goes wrong, you know, you better start praying because there's nothing else that can help you. So that's why, you know, there's so many fatalities, unfortunately, when it comes to this. Yeah. When? England. So it's a British car. Yeah. So it's always been the British and the Americans. They've always had sort of a tit for tat. So one would get the record, then the other one, then the other one. And I think this one, there was some collaboration with the Americans as well. But yeah, it was mainly a British design, and you know, it was made here, and it's still here as well. So not far away.
What do they do with the other parts of the Bloodhound?
What does it do with the what? Sorry.
The other parts of the Bloodhound.
Oh, that is still, it's in a big warehouse somewhere, I think over in Peterborough somewhere. So what they've done is they've mothballed it. So mothballing means basically when you put something away for an extended period of time, just in storage, up until the time when somebody has got the money or the will or the inclination to go back and redo it again. But again, I suppose maybe when you look at people flying to space and potentially wanting to go to Mars and things like that, I think maybe, you know, trying to go as fast as you can on land may not seem as important. So people may have kind of moved on to other things and stuff as well. Because something like this would have cost, you know, tens of millions of pounds, maybe hundreds of millions of pounds to get off the ground. Because it's not cheap, because everything for this car would have been made individually, it would have been made bespoke. So it's not like you go to a car part shop and you need a part for your car and they say, okay, yeah, we've got it on the shelf or we'll order it in. Everything has to be made specifically. And the people to make it, they're few and far in between. The materials that they use, again, few and far in between. So most of this, I guess, would be titanium or aluminium. And titanium itself is really, really expensive as well. So I don't know if you guys are into planes and stuff, but there's one plane that's made purely out of titanium. Anyone know what that is? It's the Blackbird, which was the American sort of spy plane, and that was made out of titanium because that was going, that could get to over 3,000 miles an hour. So you could actually follow the sun as you go around the curvature of the Earth. But again, if you like plane museums, they have got one of those, or a museum in Cambridge. But again, you can kind of Google that and have a look. But it just shows that all this kind of stuff, it's just going from the human mind and the human want to excel at everything. And that's what you should be doing in everything that you're doing. You know, whether it's your schoolwork, whether it's your sports, whether it's anything, just do the best that you can, because these things wouldn't happen if people just kind of just said, oh, that's it, that'll do, that's enough. You know, we'd never get anywhere. So that's what, you guys should be doing. Right, so that brings us to the end. Any questions, any more questions for today? What's the what, sorry?
How fast is the second base car?
I think the last one before that was around about 680, 690 miles an hour. Yeah. So I think, and that was an American car. That was an American car. Yeah, something like that. The fastest water vehicle, not sure, but I think from memory, it's obviously going to be less than this. But again, in the Lake District, Lake Coniston. Anyone know where Lake Coniston is? Okay, it's a big open expanse of water. It's a freshwater lake, normally quite still. And again, there's one of the guys who set some of the early land speed records, and he unfortunately passed away because his boat actually flipped up. I want to try and get a slide of that for in the next week's presentation. Yeah?
What's the slowest ever car?
The one that's stopped, the one that's not moving. So any of the ones that are parked outside, literally. So velocity is 0, speed 0. Yeah. So I don't know. Should I say, maybe one of the early ones, maybe one of the steam powered ones from before. I don't know.
What's your favorite car?
My favourite car, the GT40. The GT40. So the one that we went back, the really nice looking one. Hold on, let me go back. Yeah, that one. Somewhere here. There we are.
That's your favorite car?
That's my favourite car. That's literally like, poster car for me. Poster car for me. Even today, I mean, this is a quick car, and this was designed in the 60s.
What do you like, the shape, the drive?
I've never driven one. No, I've never driven one. But the one thing, I've never been a fan of actually paying to drive cars. People hire cars. I've never done that. I've never seen the thought of that. I mean, there's obviously places you could probably pay to do it, but no, never driven one. But I just like the look of it and the backstory behind it. Anyone watch a movie, Ford versus Ferrari? Yeah. Yeah. What do you think of it? Yeah, it's a good movie. If you like car movies, that's definitely a good movie.
What's the story behind it?
Well, basically, Ford Motor Company wanted to buy Ferrari because they were in. I mean, Ferrari as a company have always had financial problems. So they had the racing side, which were doing Formula One, and then they're doing the road side to make cars, to sell cars, to have enough money to go racing. So that's what their business model was. And Enzo Ferrari, I mean, he was a racing driver, and that's what he wanted. So he just started selling cars to public because he wanted to fund his racing team. They were in trouble, and obviously Ferrari is Italian, and at the time Fiat was a big sort of nationalised car company in Italy, and everyone knew that Ferrari was in trouble. So Ford said, look, we'll buy you out, or we'll do a partnership, and they said, look, you can keep the racing side, we'll make and build the road cars, the Ferrari badge road cars, but we'll just keep giving you money to go racing. And Ferrari himself, he was a bit of a nationalist. He didn't like the Americans. He didn't like the way Ford did things. He didn't like the Ford cars, and his basically words were somewhere along the lines, I'd rather let my company go to pot than to sell my company to you, who build these second-rate rubbish type cars and stuff. This is, and so then what obviously Ford did was they said, okay, fine, we're going to design and build our own race car. And that's what they did. And on the first season that it was entered, it came first, second, and third at Le Mans, which is like, I mean, Le Mans is in France, and it's like a big 24-hour race and stuff. And even if a car can finish that, that's a big thing. Because if you imagine a car being driven for 24 hours at full pelt, only stopping for fuel and a change of driver, because even the drivers change over, it's a big thing. So they built this car, went racing and came first, second and third. And I think they won 3 or 4 years on the trot as well. So it wasn't just kind of a one-off. And Ferrari kind of went into the dust and stuff. So yeah, that's the story behind the car. But for me, it's just the way the car looks as well. Yeah, quite a cool car. But apart from obviously the slightly dangerous fuel tanks on the sides and stuff, the bladder fuel tanks. Right, any more questions?
You know, on that fastest car, what's the note 60 on it?
Not sure. Pass. Yeah. So to be honest, I don't think it's going to be that quick because if you imagine if you've ever been on a plane, when the plane's taken off, it starts moving off quite slowly, a jet plane. And then as the thrust of the engines comes in, as they go on full power, that's when it kicks you into the back of the seat. So I think 0-60 is probably not that quick, but it's actually the top speed which is the most important thing. Any more questions yet? Favorite fighter jet? Yeah, for me, it's got to be a Spitfire. So one of the World War II ones. Again, there's probably sort of newer fighter jets out there and stuff, but for me, I think it's just a cool looking shape, really. What about you? Hurricane? Yeah. Well, people think World War II, I mean, the Spitfire was the one, but it's actually, there were more Hurricanes made, and they had more sort of enemy downs as well. Yeah. Cool. Any more? What car do I drive? I have come today in my Peugeot 107. Any more questions? Any more? Cool. So inshallah, we'll see you guys next week again. Hopefully we'll be a bit more organised. We know what we're doing now, and we can get going from the off. Yeah. Okay. Thanks, guys.